Okay, good. So we've discussed points and lines, and now let's go on and discuss planes. A plane is another undefined term. It is a flat surface that extends without end in all directions. It has two dimensions, length and width. So picture this. Imagine that you're sitting at a desk. I'm going to draw here like a table. Has four legs to it. Okay, and this is the ground somewhere down here. And the table has a surface. I'm sort of drawing the surface in a way like you can see through it, like it's a glass surface. And each of these are the legs of the table. Well, this flat tabletop surface is very much like a plane. It's a part of a plane. But if you imagine that this tabletop surface goes on forever in this direction and forever in that direction, then you've got a plane. Now, a plane can be named by any three non-collinear points that lie on the plane. So, for example, if I have a point here that's point A, and I have a point over here that's point B, and let me pick a non-collinear point. So the line AB would be this way, it would go between A and B, but I'm going to pick a point C somewhere over here. So clearly these 3 points are not collinear with each other. But they're all resting on top of the tabletop. So think about, on this table you've got 3 points. Those 3 points determine the plane. They determine the plane ABC. Every 3 points determine the plane, as long as they're not collinear. So we would denote that through notation this way, ABC. We could call the plane that we just drew here ABC. We can also name the plane by using a single uppercase script. So just like with lines we use lowercase script, for planes we can use uppercase script. So let's say I use a script M, and I say, well, this plane is plane M. I can denote that using a single uppercase script letter. Okay. We're not going to worry about this last one. We'll be covering that later. Coplanar. Coplanar are points that lie in the same plane. So here we've got, by definition, A, B, and C are coplanar because they define the plane. But if we had, let's say, another point over here, D, that was resting on the same tabletop, it would be coplanar with A, B, and C. Okay, and just like we had collinear and non-collinear, so we also have planar and we have coplanar and non-coplanar. Points that do not lie in the same plane. So let's go back to our drawing of a table. And let's say that on the floor, somewhere beneath the table here, we have point E. And of course, this is the tabletop. It's going out in forever in both length and width directions. But it never includes point E because point E is below it. It's on the floor. So we would say that point E is, we would say, let's say that points A, B, C, and E are non-coplanar. Okay, because there is no one plane that contains all 4 of these points. Space is our next term to discuss. Space really is boundless, and it includes anything. It includes all locations that are possible, so that everywhere is space. Anything you can point to in this world or in outer space or anywhere in the universe is part of space. So space is boundless, and it has 3 dimensions. We can call them length, width, and height. Or if we were using coordinates, we can call it x, y, and z. Parallel lines, I'm just going to mention briefly. We're going to talk about parallel lines a lot more in other units, but I'm going to draw a pair of parallel lines for you as best as I can. They're lines in the same plane. Okay, so these are both in the plane of the same sheet of paper, and they're always the same distance apart. Okay, they don't exactly look it because I didn't quite draw it perfectly, but theoretically you want this distance, let's say from here to here, let's say this distance is 2. You want that distance to be the same as the distance between the lines over here, which let's say should also be 2. So, in other words, these lines are always going to be the same distance apart, no matter how far into infinity you measure them one direction or the other. they stay the same distance apart. Okay, and they never intersect. They don't intersect. Very important. Parallel lines do not intersect. Skew lines. Well, skew lines are more of a three-dimensional concept, and let me try to demonstrate skew lines with with this desktop that I'm writing on right now. Lines that are not in the same plane and do not intersect are skew. So two things have to be met. They can't be in the same plane, and they cannot intersect. So let's say I had a pen lying on top of my desktop like that, and just think about the pen as if it were a line. Okay, obviously this is too thick to be a line, but think about it like it was a line. Now, if I put another pen like this in the same plane, then they clearly intersect. They clearly touch each other. Okay, so they're not skew because they're in the same plane and they are intersecting. Well, if I took this black pen and I stood it up like this, okay, so now it's not in the same plane as the red pen. It's not lying on the same tabletop-like surface. And furthermore, it doesn't intersect. The line that's represented by this black pen never intersects that red pen, because this black pen either goes up like that or down through the tabletop, and it never intersects the red pen. So that would be sort of a way to represent skew lines, lines that are not in the same plane and do not intersect. Well, we've sort of been using the word intersection. We've been using it because we kind of know what it means already, but its formal definition is the set of points that are in both figures or where they cross. Okay, so if we had two lines, let's say we had a line here, AB. Okay, remember I can name the lines by a line by any 2 points on the line. And let's say I had another line here that crossed line AB, points with points C and D on it. Then these are not parallel lines. They don't have the same distance between each other. They intersect. We can name the point of intersection point E if we want. And that point E is the only point that both lines have in common. Okay. Now you can also have intersection of planes. So let's say we had one plane here. Okay. This is a flat surface. And then let's say we had another plane sort of on an angle to that plane. Crossing it like that. Okay? Sort of picture the pages of a book. Okay? The first plane is sort of the book open, and the second plane is sort of a page that's being turned, but going in an infinite direction in both length and width. Those two planes intersect. And if two planes intersect, then they intersect in a straight line. Okay, so if two planes intersect, then they always intersect in a straight line. Do planes always intersect? No. Just like you can have parallel lines, you can have parallel planes. So for example, if this hand is one plane and this hand is another plane, I can have both my planes like that parallel to each other and they'll never cross. We have two more terms to discuss. One is called concurrent lines. Okay, concurrent lines are three or more lines that pass through the same point. So let's draw that. Three or more lines that pass through the same point. Let's say this is a line. Let's say this is a line. Where would that third line have to go through? You got it. It would have to go through the intersection point of the first two lines. So if we drew another line, it's not a great line I'm drawing there, but okay. I drew it, and now you see we've got three lines that pass through the same point. We could draw a fourth line passing through the same point too. That would make all four of these lines being concurrent. And our last term is postulates. Postulates. Postulates are statements that are accepted as true without proof. And we've sort of already talked about several of these postulates. 2 points determine a unique line. That's one of our postulates. If 2 distinct lines intersect, then their intersection is a point. That's a second postulate. 3 non-collinear points determine a unique plane. We've used that one too. That's a postulate. And finally, if 2 distinct planes intersect, then their intersection is a line. Okay. Well, I'd like you to draw out all 4 of these cases for yourself so you could better picture it. Hopefully this is going to give you some advantage as you start the lessons, because you'll know some of the basic vocabulary that you need to know to make sense of the rest.